it at that limit, and it'll come out to be the same thing. That's the final step. The limit as x goes to a of f of x over g of x is f prime of a over g prime of a. Note, you're not using the quotient rule. You're doing the derivative of the numerator over the derivative of the denominator. Raise your hand if you remember talking about L'Hopital's rule in this class. Everybody was present, so raise your hand. Good job. So the key, though, is you can do it multiple times because of the more general form, which states that if x goes to a of f of x over g of x, you can set that equal to the limit as x goes to a of f prime of x over g prime of x. Meaning, how many times can you theoretically do L'Hopital's rule on a given problem? Yeah, theoretically forever. We can come up with something where it keeps on looping, right? The key, though, is you need to make sure that the limits exist. So provided the limit on the right exists. You know, if you're turning into something that doesn't, it don't work. So the challenge is this. L'Hopital's rule applies to limits involving infinity, meaning there are two indeterminate forms, either plus or minus infinity over plus or minus infinity, or what's the other indeterminate form? 0 over 0. You have to check to see if you have an indeterminate form before you can use L'Hopital's rule. What happens if you use L'Hopital's rule on something that is determinant, meaning isn't 0 over 0 or infinity over infinity? What happens? Do you know? Anybody do it? I've done it by accident before. You get nice answers sometimes. And you're like, yeah, the answer is 7. What happens if you integrate over a vertical discount, like a vertical asymptote? Like let's say I asked you the integral of, I don't know, -3 to 3 of 1 over x dx. What's the problem with just doing that integral straight out? You can't integrate across 0. 0 is not in the domain, right? There's a vertical asymptote at x equals 0. But if you do the integral out by hand, sometimes you'll get nice answers like 5. And you're like, yeah, the answer is 5, but it's clearly not. If you apply L'Hopital's rule to something that is determinate, meaning not indeterminate, you end up sometimes with clean answers. So you have to notice, when is it indeterminate? When is it not? Sometimes I'm going to say, use L'Hopital's rule. Sometimes you're going to be like, I have no idea how to do this limit. And then one of your tools is going to be, okay, I can use L'Hopital's rule if what? I have a indeterminate form. Indeterminate form. So how about you get to the board, everybody? Get to the board right now, everybody. Get to the board. Or you need practice, you must use logarithmic differentiation to find the key to this, which is d dx of x to the x. This is called logarithmic differentiation. You must know how to do it. You can find them, practice them, which we're going to do right now. Hey, look, did we get it right? What did we get? Did we get it right?
Yes.
We did that work right there. That's all of it typed out in like 2 lines. It looks a lot worse when you do it in 2 lines. So here's the thing. Is the indeterminate form always obvious? No. Like, for example, do you see a division there immediately? No. But can you rewrite that? Exactly. So what is that? It's x over what? And that is infinity over infinity. So by L'Hopital's rule, which I want you to write equals h. Do you see that, everybody? That means you're applying L'Hopital's rule. Please still write the limit in. Don't drop the limit. What's the derivative of the top? 1 over. So that's just going to go to 0, and you're done. Wonderful. Sometimes it's slightly hidden. Sometimes it's hidden a little bit more. So there's a battle that goes on, everybody. What happens when you multiply 0 times infinity? Well, if this is going to 0 and that's going to infinity, what happens when you multiply them together? Depends. Infinity could win. Boom. 0 could win. Or you can they could tie, and it could be like 7. I love those answers. When you multiply something that's getting infinitely small times something that's getting infinitely big, and the answer is like 5. I love that stuff. What about infinity, something going to infinity and going to something to the 0 power? What happens? Who knows? Who knows? You don't know, right? The point is, in the eternal battle between 0 and infinity, there are multiple types of answers. And we have a great tool now, which is called L'Hopital's rule. The thing is, we need to put it in the proper form to apply it. So this one, for example, see this one? Do you see a fraction? Bukan? Do you say mekan? Mekan? How should bukan? Mekan. Mekan. No fraction, right? 可是, can you force it? Mm-hmm. Ready? Here's how you force a fraction. You make it ln x over what? 1 over x. Is that the same thing? Is that the exact same thing? We've now made it worse, but it helps us because now what form do we have? What's the top go to, everybody? As x goes to 0 from the right. negative infinity, and this one goes to, so is that an indeterminate form? So what do you take on the top and bottom? Do you take the, so what do you get on top? The limit as x goes to 0 from the right of what? 1 over x all over. And you might be tempted, man, I'm just going to use L'Hopital's rule again. Don't forget that you can simplify. What's another way to write 1 over x? So what does that actually equal? The limit as x goes to 0 from the right of what? X to the negative x to the what? To the 1. Negative x to the 1, right? Do you agree? So that's just equal to negative lim x goes to 0 from the right of x. So what's the answer to this? 0. Done. Don't forget to simplify. So sometimes you have to force it. Do you agree? That's not totally obvious, but hey, you can make it. What about this one? Is this really similar to what we just did? Yeah, it's similar to that thing, right? Do you see x in the base? Yeah. Do you see x in the power? So you use, what was that method called? Logarithmic differentiation. Real popular at the lunch table today. I know. So this is what you're going to be talking about. So the first thing you do is you say y is equal to the limit as x goes to infinity of x to the 1 over x. Then what do you do on both sides? Take the, well, we want to take, but first what do we add in? Yeah, and we like ln, right? So we do this. I'm going to give you something here. Limit as x. I know it's super exciting, Chip. I know it's all good. It's all good. I'm tired too. It's fine. I'm going to give you something here that we don't need to prove. If you're taking the natural log of a limit, you can reverse them. The natural log of a limit is the same thing as taking the limit of the natural log. I'm giving that to you. We don't have to prove it. I'm just take it. Okay? You're like, we were taking it without complaint. You don't have to emphasize it. So what do you end up with here? The limit as x goes to infinity of what? ln of. And I did that because what can I now drop to the front, Chip? Tajao, Chip. Nito.
You can rewrite it as
yeah.
1x over x.
You can write it as, well, yeah, you could. So you have the limit as x goes to infinity of ln of, ln of x all over x, right? Do you agree with this?
Yeah.
Oh, now we can take the derivative of both sides. Do we have an, let's just look at this right here. Is that an indeterminate form? What happens as x goes to infinity on the top? Blows up. Bottom? So can you do L'Hopital's rule? Because it's what? Infinity over infinity. So we say apply L'Hopital's rule, so we know it's going to be equal to the limit as x goes to infinity of what? Over? No, over e. Just 1. And what does that mean? What's that limit? That's just 0, right? So we now know, what do we know? ln of y is equal to what? 0. That's log form. What's it in exponential form? E to the 0 equals, so what does y equal? 1. And y was our original thing we wanted, right? So what does this equal? So that's logarithmic differentiation strikes again. I know. Believe me, I know. That is logarithmic differentiation strikes again. Do I? Yes?
Can you explain how?
We did see. We kind of did. I like it. We did most of it. Can you use the same mechanism to do that one? Uh-huh. This one I'm going to leave to you guys. This one I'm going to leave to you to work on all by yourself. All by yourself. You don't like my singing? Go ahead. Thank you for giving away the end of the story. Thank you for the punchline, everybody. Good job. Good job. What does the inside go to right here? Goes to 1, right? Did you read? It's going to 1 from the right. Do you agree? What is this going to? Infinity, right? So the thing underneath is getting really close to 1, right? But the power it's being raised to is getting infinitely big. Theoretically, like 1.2 to the billion power, 1 to 100 million, right? Is that big?
Yeah.
That's huge, right? But as you make the decimal smaller, theoretically it gets smaller, but then the infinity power makes it bigger, right? So let's say we wanted to figure out what this is. Y is equal to the limit as x goes to infinity of 1 plus 1 over x to the x. What do I take on both sides? ln. Can you do this with regular? You can. I firmly believe we use ln a lot because it's 2 letters instead of 3. I'm not kidding. What can we now? Oh, can we switch ln and limit? I told you you could. So you're like, take it. So what do you have here? Limit as x goes to infinity of what? And you can bring that x to the front, right? 1 plus 1 over x like this. Do you agree with that? Okay, we want this, right? We want that limit. We want that limit. Is that an indeterminate form? Do you see a fraction yet? No. We have to do a little bit first, right? A little tiny bit. So what do we turn it into? Limit as x goes to infinity of what? ln of
1 plus 1 over x
over 1 over x, right? Is that an indeterminate form? Yeah, what does this go to? 0, right? And what does this go to? So we have 0 over 0, so we can apply L'Hopital's rule, and we get x to infinity of, what's this going to be? 1 over what? 1 plus 1 over x, right? Times negative x to negative 2, right? All over what? Negative x to negative 2. Do you agree? You agree with that? Oh, wait. Does something cancel? What cancels? Hey, that goes away, right? And what are we now left with? Just equals, don't pack up yet, almost to the punchline, to infinity of what? 1 over 1 plus? Oh, but what does that equal? What does that equal? Just 1, right? So what did we just show? We just showed that ln of y is equal to 1. So what does y equal? E. So what does this whole thing equal? You just proved another definition for the number e. Isn't that awesome? I think it's awesome. Okay, get out of here.